Welcome back. Geometry section 7.4 today, proportions, parallel lines, and parts of similar triangles. Start off with a definition. Triangle proportionality theorem, which states in our given figure, if TU is parallel to QS, then RT over TQ is equal to RU over US. In general, the theorem states if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. And that's what we have here overall. We have TU being parallel to the base, which is QS, and then therefore it divides it into a proportion. We have the converse to that, the triangle proportionality converse. In general, it states if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So in this case, if RT over TQ is equal to RU over US, then the two lines TU and QS are parallel. So we have the triangle proportionality theorem, the triangle proportionality converse. And we have just formally written from our text. And now we'll apply it. It says, finding length of sides. Given AB is parallel to ED, find the length of EC. So we have the X already given to us. We have lines AB and DE being parallel. So applying the theorem we just talked about, we can make this proportion statement. DC over DB is equal to EC over EA. Plug in the information that we know. These are 4 over 8 is equal to X over 12, and then cross multiply and solve. And at this point in time, we should be pretty quick with cross multiplying and solving. X equals 6, final answer for EC. Similar statement, given UI is parallel to VX, find YX. So VW is a length that we do not know. So we'll put that in as a variable X. YX is the one that we're solving for. We have Y. I definitely can get rid of my X right away. I know that VW is going to be 15. If I take 18 subtract 3, we'll use that in a second then. Alright, proportionality statement. We know that we can make the statement that VW over VU is equal to WX over XY given the triangle proportion statement. Filling in the information we know. 15 over 3, there's that 15 I was talking about, is equal to 16 over xy, or I just call it y. Cross multiply and solve, we have 15xy is equal to 48. Solving then as I switch it over to the variable x, we'll just make this x here. To coincide, 48 over 15 simplifies down to 16 over 5. Again, the key is about the proportion, okay, getting this statement. Alright, if we know that 15 over 3 is equal to 16 over the length I'm trying to solve for, we can cross multiply and solve. Alright, finding the length of the side, given that RT and VU are parallel, and some information about those sides, find the length SU. Come up with our proportion. We know that SV over VR is equal to SU over UT. Filling in the information we know then that VS is 3, VR is 8, SU is the value I'm trying to solve for, it's X, and then UT is 12. Cross multiply and solve. X equal to 36/8, which can be simplified down to, of course, 4 and 1/2 as a mixed number, more preferably as an improper fraction. We'll write that now as 9 over 2. So the book may have it down for a mixed number. We're going to prefer it as an improper fraction. Easier to work with. Alright, good. Keeping in the same theme, try to solve for BY in the situation. Proportion that we can set up, we know that 10.5 over 4 is equal to X over 6. 4X is equal to 63, and X is equal to 15.75, which is D. Again, straightforward. Alright, different type of question here. Determining parallel lines. Is MN parallel to GH given the information? So this will be using the converse of the triangle proportionality statement. Alright, what do we need? We need to have a proportion hold true. So I put the sides together. LM over MG is 56 over 21, which is 8/3. LN over NH is 48 over 16, which divides down to 3 over 1. Since 8/3 and 3 over 1 are not equal, then we know that the lines are not parallel. Again, this is using the converse that we talked about earlier. Alright, same question. In the triangle, if we have XY as 15, we have YZ as 25, we have WA as 18, and AZ as 32. Can you determine, are they parallel, WX and AY? Proportion 32 over 18, is that equal to 25 over 15? Simplifying here, this left ratio will simply be 5/3. Okay, taking 5 out of both top and the bottom. The right proportion, taking out, if we take out a 2, we end up with 16/9. These two values are not equal to each other, so therefore the lines are not parallel, again, which will be B. So again, determining parallel using the converse. Do you have true proportions? Alright, next example. Determine whether GH is parallel to FE, given the information above, which is that DH is 18, HE is 36, and DG is half of GH. Our proportion statement, we have DG over GF is equal to DH over HE. That has to be true. DG is equal to half of GF, so therefore we have a ratio of 1 to 2. Since DH over HE is equal to 18 over 36, which is also 1 over 2, the sides are proportional, which means that the two lengths, GH and FE, are parallel by the triangle proportionality converse. Alright, new theorem. If three parallel lines intersect two transversals, okay, again, transversals are lines that cut across two or more lines, then they divide the transversal proportionally. Specific example here with the picture. If R is parallel to S and S is parallel to T, and L and M intersect R, S, and T, then we know that line segment UW over line segment WV is equal to VX over XZ. Let's apply that theorem. The top has the same statement. We also have the triangle mid-segment theorem. A mid-segment of a triangle is parallel to one side of a triangle, and its length is 1/2 the length of that side. So here we have the picture. If J and K are midpoints of FH and HG, respectively, then JK is parallel to FG, and JK is equal to half of FG. So that is if we have the mid-segment. Okay, so we have a mid-segment theorem, and we have proportional parts of parallel lines. Alright, now let's apply that. In the figure, DE and EF are mid-segments of triangle ABC. Find AB, FE, and the measure of angle AFE. So again, we have to apply what we just talked about with the mid-segment theorem, which is that we have parallel lines, and the length is exactly half of the base. Okay, we know that ED is going to equal half of AB, okay, by the mid-segment theorem. That means that 5 is equal to half of AB, and AB then has to be 10. Multiplying by 2 over 1 reciprocal on both sides, we have AB equal 10. Also, we know that FE has to be half of BC, which means that FE is equal to half of 18, which leaves us with FE is equal to 9. As far as the angles are concerned, measure of angle AFE is the angle we're trying to find. So that's AFE, that's this angle here. Okay. We're given that FED is equal to 87. Okay. AFE and FED are congruent by the alternate interior angles theorem, and therefore we have congruent angles. Seeing as how that, again, AB and ED are parallel to each other, so if this line extends out, we have alternate interior angles, which leaves them to be congruent. Alright, next statement. In the figure, we want to find BC, DE, and AFD. So BC, this length right here, BC. If we have mid-segments, that means that FD is half of BC. So therefore, using the mid-segment theorem, we know that the length of BC has to be C, 16. Looking at DE, we know that if AC is 15, I'm trying to find DE, and this is a mid-segment, then I know that's going to be half of that, which will be A, 7.5. And lastly, looking at AFD, angle AFD, we know that DE is parallel to AC. If we extend out our line here, we have alternate interior angles, so therefore 122 is the measure of that angle. Again, just applying the rules of the mid-segment theorem. Alright, next theorem. The theorem states, if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. This is a specific example. If CD bisects angle ACB, then AD over DB is equal to CA over CB. So this is if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So we always want to kind of start in the order too. If we have AD over DB, then we know that AC over CB. Okay, if you start with A on the top, you have to keep A on the top for the next proportion. Okay, again, congruent parts of parallel lines from transversals, and then the triangle angle bisector theorem, as this one is stated as. Alright, let's apply these. Alright, given 1, 2, and 3 being congruent, find TU. So that means if we have 1, 2, and 3 being congruent, that means that all of these lines are parallel by the corresponding angles converse. So therefore, if they're all parallel, then by the previous theorem that we have, we can write a proportion which will find TU. We know that PQ over QR is equal to ST over TU. Filling in the information that we know that 9 over 15 is equal to 11 over X, 9X is equal to 165, and X is equal to 55 thirds when we simplify. Again, the key is how do we get the proportion and what do we use? Once we have the proportion, it's pretty easy to solve. Alright, similar one. We have maps. It says the figure shows the distance between city blocks, find X. So all the lines, all the streets are parallel as given, parallel, okay, here. So therefore, we have 13 over 26 is equal to 16 over X as our proportion, okay, or the opposite, 26 over 13 as X over 16, just as long as you're consistent, cross multiply, and solve. X is equal to 32. Okay. Use congruent segments of transversals. Given the information we know, we don't need to know too much. We don't need to know too much else. Then, if this segment is equal to this segment, we can set them equal to each other and solve. Same thing with the top here. If this segment and this segment are equal to each other, we just write two expressions that equate those two. So to find X, 3X minus 7 is equal to X plus 5. Simplify here and solve. We're left with X equal to 6. To find Y, we'll do a similar process. 9Y minus 2 is equal to 6Y plus 4, and solve. Final answer, Y is equal to 2. So X is equal to 6, Y is equal to 2. Don't think too hard when it has simple statements like putting two congruent segments equal to each other. Alright, now we'll apply the triangle angle bisector theorem. So we want to find x. We do have an angle bisector. So our proportion setup will be that x over 6 is equal to 15 over 9. Again, if we started with this side with the x, we have to start with this 15 for the next ratio. Okay, proportion holds true, cross multiply and solve. You're left with x is equal to 10. Similar type problem here on the left, find n this time. So if we start here, we'll have 5 over 7 is equal to n over 21. We'll have 7n is equal to 110, which leaves us with n is equal to 110 divided by 7. Okay. I'm sorry, it's 105. I made an error here. This is not. I was trying to look for the solution. It wasn't up there. 21 times 5 is not 110. It's 105, which will mean this is also wrong. So we have that. We'll have 105 over 7. Excuse me. And that is, of course, B15. Alright, again with the angle bisectors, given that CAD is congruent to DAB, okay, CAD and BAD angle bisectors, find DC. So now the hard part is not necessarily the proportion, which I still hold to be true as AB over AC equal to BD over DC, but what do I put down for my variables? I can't have it just be 14. I'm going to have one be X. I'm trying to solve for DC, so I'm going to make DC X. If DC is X, that means that DB has to be 14 minus X, because whatever X is, that length DB will be 14 minus that number. So I can put my expression into my proportion, and I have 9 over 15 is equal to 14 minus X over X. And at this point in time, it's just cross multiplying and solving the expression. 9x is equal to 210 minus 15x. We have 24x is equal to 210. Divide by 24 and simplify. Final answer, x then, is 35/4. Alright, looking for x and y. Given KL and MN are parallel, we have our proportions. JK over KM is equal to JL over LN. Simplifying here, again, if we know that this length LN is X, this has to be 37.5 minus X, and that's what we have in our proportion to solve for. Going through the solving, X is equal to 22.5. Okay, last question. KL is parallel to MN. Find X and Y. We already found X in the last slide. Solving for Y then, we'll use the proportion. JK over JM is equal to KL over MN. Simplifying that then with our information, we know that JK is 9. JM is a combination of JK and KM, so that's 22.5. KL 7.5 and MN is what I'm solving for. So we'll leave that as Y, cross multiply, and end up with Y is equal to 18.75. Alright, that ends the lecture for today. Questions we're going to look at are from page 489, numbers 1 through 27, 33 to 38, and from page 499, 4 to 5, 11 through 14. Thank you.